So as you know, there are 6 key safety steps that we require all operators of the CNC machine tools at WPI to follow every time they operate the machine tool. We want you to simulate in the CAM software. So I want you to simulate in the CAM software and understand what the computer thinks the machine tool is going to do. You have to set tool offsets, and you have to set work offsets. And so this tells the machine tool about the tools, about how long the tools are, what the diameter of the tools are, and it tells the machine tool where you physically put the workpiece in the machine tool's work envelope. So you simulate in the CAM, set the tool offsets, set the work offsets, simulate. On the controller. So I want you to simulate on the controller, and that tells you a few different things. One, it tells you if you physically put the workpiece in a spot that the machine tool can reach. So it might be possible to put the workpiece near the edge of the machine tool's travel and then have it be so that the tool can't reach all the positions that you've commanded it to go to. That'll tell you if you've done that. The other thing it does is if this simulation doesn't look like this simulation, it's not the same program. So if they look completely different, then you've loaded the wrong program or you've selected the wrong program, so you got to step back and check on that. So simulate in CAM, set the tool offsets, set the work offsets, simulate on the controller. We want you to reduce the rapid speed of the machine. And so we don't tell you what number to reduce that to because, it depends on the machine, it depends on you, it depends on the program. So it's up to the operator to pick which reduced rapid speed to use. Now, in some of the lab exercises in the introductory classes and things, we will specify particularly which rapid speed we want you to use that day on that machine. But in general, it's up to you to be able to reduce that rapid speed so that you can stop the tool. You have confidence you can stop the tool before it reaches the workpiece so that you can check the distance to go. And so each tool, as it's approaching the workpiece for the first trip, we want you to hit that feed hold button. We want you to look inside the machine. If your simulation showed the tool coming down on this side of the workpiece, and you observe the tool's coming down on this side of the workpiece, something is wrong. Stop the program. If your simulation showed a 1/2-inch end mill coming down at this location, and you see a 3/8-inch drill coming down at that location, something is wrong. Stop the program. The other thing that you're going to do is you're going to stop it, and you might stop it when it's about 1 inch above the workpiece, and you're going to look inside. You're going to look at the line of code that's flowing by on the controller, and that line of code will be highlighted, the one that's currently active, and it'll be something like z equals 0.1 or z.1. So we'll be on a G00 line or a G01 line, z equals 0.1. You're going to look in there. You're going to look on the controller where it says distance to go. If you stop it about 1 inch away, if it's going to the top of the workplace and it has about 1 inch left to go, everything's okay. Press the green button and proceed. If you stop it about 1 inch away and it says that it's got 5 more inches to go, something is wrong. Stop the program. So, all of these steps are important and they keep you from crashing the machine tool. But if you do this step correctly, you will avoid almost every crash that could possibly happen in these machine tools, assuming you've done these steps correctly also. Let's see what the class said. So we did this exercise, and I said, what is the most important of those 6 safety steps, and why? So I'll just quickly read through the cards that the class said. So the most important machine used, something went wrong. Yeah, obviously you don't know what the safety steps are. Most important is check the feeds and speeds. That's not one of the safety steps. Tool speeds because it might break. Yeah, I know. You didn't even answer. Stopping the tool before it hits the material and checking the distance to go. I got 1 correct. Having the PLA sign off and check the work. Yeah, not necessarily. Stopping to check. It won't go through the thing. I think they mean check the distance to go. Distance to go. Simulating tool paths is most important because it can prevent some of the errors. I still vote for check distance to go as being the most important, but at least you knew what the safety steps were. So simulate before the machine, errors. So, okay, so it's to simulate Turning is on and lathe and milling is on and a mill. So you're talking about, oh, that's, sorry, side one. Let's look at side two. The operator checklist, simulating and cam to make sure everything's okay. Let's say simulate, 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 distance to go. All of them are important. Failure in any way can result in injury or crash. I agree, but I told you to pick the most important, so you fail. Checking to make sure that it doesn't crash. Yeah. Distance to go. Name. Yeah, I don't think filling out your name is the most important. Getting signed off. Check to complete. Yeah, I can't read that. Check the offsets. Most important is simulating. Simulate, simulate, simulate. Most important check is the operator. Simulate. Based on what I've seen, the offsets seem fairly important. Well, you can't do it without the offsets, but if you've screwed up the offsets, you'll catch it with check distance to go. Simulate. Distance to go. Offsets. Simulate. Reduce the rapid rate. It makes checking distance to go a lot easier. Most important preliminary simulation. Simulate. Offsets. No answer. No answer. Simulate. Not sure. At least that was an honest no answer. But I told you to take a stand. Simulate. Offsets. Set up the tool offsets. Simulate. I have read the safety info. I don't know, is there a checkbox that says that? Not related to this. They're all important because the parts, yeah, they're all important. I told you to pick one though. Simulate. Simulate. And you guys like simulate. Most important is deciding if it is X, Y, and Z axis. Is the step with deciding the X, Y, so that must be like handle jogging or something. Most important is check distance to go. No answer. Distance to go. Checking with the TA. Simulate. Simulate. Distance to go. Simulate. Distance to go. Simulate. And distance to go. Wow! So I thought it was check distance to go. You guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of you get an A. All the rest of you fail. No, but so I like simulate because it helps you understand what you're seeing with check distance to go. In fact, sometimes when I'm checking the distance to go, I'll go back and run the simulation again just to make sure that I don't misunderstand what's going on. At any rate, all 6 steps are important. That's why we put all 6 steps on the safety checklist. And I guess when I say that I think this one is the most important, it's really because if you do this one correctly, you're very likely to catch any of the crashes that might happen in the machine, even if you've screwed up all the other ones. So thanks very much. Keep paying attention in class. Keep paying attention in the lab. I'll see you later.